RCADT, Research Center for Advanced Decision Technologies is pleased to invite you to participate in the postgraduate level course. Oil and Gas Sector, Enterprise-Wide Optimization. A different course in advanced optimization. HI operates as a knowledge factory in artificial intelligence and advanced mathematical modeling, focusing on artificial business management, autonomous AI that guarantees objective decisions. Artificial brains, integrates organizational decisions based on neuroscience. Enterprise-wide optimization systems, EWOS, customized AI that integrates multi-problem model systems, and high-complexity mathematical models, traditional models that are part of our artificial brains. The course covers the math modeling of the following process in owned supply chain. The course covers the math modeling of the following process in owned supply chain. The course covers the math modeling of the following process in owned supply chain. RCADT and/or HI issues a certificate signed by the scientific coordinator, for which the student must participate in at least 20 conversation sessions. The instructor of the course is Engineer Jesus Maria Velasquez Bermudez, Ph.D., who, in 2024, won the Artificial Intelligence Award of the Industrial Engineering and Operations Management Society, IEOM. Hypothalamus Artificial Intelligence brings real-world electricity business optimization to academia, to teach the implementation of optimization systems across the enterprise. HI has established technology and commercial agreements with organizations committed to highly complex mathematical modeling, such as GAMS, General Algebraic Modeling System. GAMS supports HI courses by providing students with temporary licenses to use during the course. Then, the material that HI delivers in GAMS programs may be used by students. The support also includes 1 or 2 lectures given by GAMS, to present its optimization technologies. RCADT, Research Center for Advanced Decision Technologies, is a division of Hypothalamus Artificial Intelligence Incorporated, USA, oriented to research, technological development and innovation, RAND+I, in high-complexity mathematical modeling, with an emphasis on optimization, whose mission is to bring its benefits to humanity, which involves enable professionals to successfully apply optimization technologies in their organizations, and be entrepreneurs and mentors of new companies, spin-offs, that bring the benefits of optimization technology to society. Currently, the central topic of RCADT's research is augmented artificial intelligence and more specifically the artificial brains. To fulfill its mission, RCADT has created a set of courses in advanced mathematical modeling that are aimed at supporting professionals interested in receiving applied training, at a cutting-edge level, based on the experience capitalized on more than 50 years executing engineering projects and development of analytical software. Artificial hypothalamus. RCADT is pleased to invite you to see the video. Courses, Applied Operations Research and Industrial Engineering. A company's value chain is made up of 2 chains, strongly interrelated. Demand chain determines all the processes that are carried out to attract customers in the markets, and supply chain determines all the processes that are carried out to produce the products that customers want to consume. The diagram presents the chain of the company's production chains that together make up the value chain. One of the greatest evolutions in the modeling of companies occurs in the interpretation of their value chain. The diagram presents the evolution of different administrative practices in companies, which are linked to technological solutions, leading to AWO. Thanks to computational power, the integration process has continued to grow. The diagram presents the original S&OP model, and the current version, which integrates more and more models. This evolution has led to modeling based on artificial hypothalamus, supported by the integration of mathematical programming and artificial intelligence. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. Those interested in learning more about artificial brains are invited to read the white paper. Oil and Gas Artificial Brains. Case Pipelines Transportation, which is part of the course material. Oil and Gas Supply Chain. The oil industry includes global processes of exploration, extraction, refining, transportation and marketing of petroleum products. The largest volume products in the industry are fuels, natural gas, fuel oil, and gasoline. However, petroleum is the raw material for many chemicals, including pharmaceuticals, solvents, fertilizers, pesticides and plastics. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. At the origin of mathematical models in computers, starting in 1947, decision support systems, which represent the optimization system of an owned company, have been visualized as composed of multiple mathematical problems, one for each line of the table, which are operated individually and communicated sequentially by humans. This way of operating produces solutions close to the optimal, but not optimal, because they generally have no feedback. The current technological revolution completely changes this approach. Today, ONG's business optimization can be visualized as a single supermodel, composed of submodels, which in turn are made up of mathematical problems, one for each line of the table, which are solved by running in parallel, autonomously, communicating with each other, and managed by a mathematical artificial intelligence, produced by a generative artificial intelligence. The image presents the main models associated with the production of oil and gas. Oil and gas enterprise-wide optimization system integrates mathematical models for each of oil and gas's supply chain links, so that supply chain planning is managed with a holistic view. Oil and gas production optimization integrates reservoir behavior as part of the optimization model. Considers four fundamental aspects: production system, reservoir behavior, operating modes of wells, and flow in the hydraulic system. The objectives of optimization models depend on the planning horizon, and can be divided into real-time, advanced control, scheduling, short-term production optimization, planning, medium-term field optimization, strategic operations planning, long-term planning, reservoir recovering optimization, and strategic investment planning, portfolio optimization in oil exploration and production. The diagram summarizes the connectivity of the mathematical elements that allow modeling the well, in the aspects related to the pressure and flow of hydrocarbons, along the hydraulic system that is part of the production system. Operations planning integrates multiple fields, which in turn comprise multiple oil or gas, which are operated by means of multi-well interconnected. Interconnection, which occurs at the surface facilities, allows gas and oil can be sent to storage for subsequent release through a transport system. The goal of optimization is to determine the contribution of each well, to meet demand while minimizing the total cost of the operation during the planning horizon, which is associated with energy consumption in the production system, more investment in adaptation of deposits when this restructuring of the productive system topology is allowed in the model. Smart grids, flue gas and hydrogen production, in oil and gas fields, are new activities that need to be optimized in the oil industry. Oil transport, trading and blending optimization corresponds to a dynamic model that optimizes oil distribution between fields, refineries and ports, the oil mix for use in refineries, the mixture of oil for export in accordance with quality standards and established supply contracts, import of oil according to offers in the spot global oil market, and import/export of oil according to offers in the oil derivatives financial instruments. Oil transport, trading and blending optimization corresponds to a dynamic model that optimizes oil distribution between fields, refineries and ports, the oil mix for use in refineries, the mixture of oil for export in accordance with quality standards, and established supply contracts, import of oil according to offers in the spot global oil market, and import and export of oil according to offers in the oil derivatives financial instruments. Pipelines planning and scheduling. The image presents the main models associated with the transport of oil and gas. Piping systems require at least 3 models to coordinate their operation. S&OP, tactical planning, on the order of months, weeks, SCH, daily operations scheduling, such as tenders planning, and RT, real-time, on the order of hours. Under the principle of transitivity of algebraic formulations, models grow in complexity, as they descend from the hierarchy of decisions. All models share equations, mainly those related to the physical process. Therefore, they can be made in a continuous modeling process. The models of higher hierarchy will be more aggregated, in order to cover long periods of analysis, of the order of the years. The emphasis of the model should include the interpretation of the economic and technological future, so it is appropriate that they are stochastic optimized. As the models approach real time, the level of detail increases, and the planning period decreases, the most important being the engineering representation of the process. Those interested in knowing the topics to learn in this part, Hi invites them to watch the video. Oil pipelines companies, enterprise-wide optimization systems. Success case, China National Petroleum Corporation. The purpose of this case is for course participants to understand the economic losses that are avoided if artificial intelligence models are used for decision-making. The function of every organization is to produce wealth for all its owners, and this is not obtained only with goodwill. The paper Operations Research Enables Better Planning of Natural Gas presents the use of mathematical optimization models for pipeline planning. China's natural gas consumption has nearly doubled in the past 5 years. To better meet demand, the China National Petroleum Corporation, CNPC, China's largest producer and supplier of oil and natural gas, partnered with researchers from the University of California in Berkeley, and Tsinghua University in Beijing to apply operations research to develop and implement new software to help CNPC to improve the management of its pipeline network. Previously, all pipeline production and construction planning for CNPC, which controls 72% of the country's natural gas resources, and 70% of its pipeline network, was done by traditional methods using spreadsheets. However, due to the increasing size and complexity of the network, the use of the traditional method resulted in excessive costs and wasted resources. Since implementing the new software, which uses a 3-stage convex relaxation method, and iterative piecewise linear approximation methods, in late 2014, CNPC has obtained approximately $530 million of American dollars in increased earnings, 2015 to 2017. In addition, the resulting increase in the efficiency of the existing pipeline network allowed the company to postpone the addition of new pipes, leading to an official budget reduction of more than $20 billion of American dollars in construction costs for the following 5 years. The image present the algebraic formulation of the natural gas pipeline transmission model. Without fear of being wrong, it can be said that mathematical optimization models are the goose that lays the golden eggs of China National Petroleum Corporation. Oil transport systems optimization corresponds to a general model, common to all types of oil products, raw, refined, natural gas and biomass, which represents the process for a specific system, including particular equations when this is required. It considers 2 types of transport modes: pipes and multimodal vehicle, like vessels, barges, train tanks, and/or trucks tanks. Kalman filter applications. Prognostic and health management, PHM, maintenance in pipelines. Those interested in learning more about these applications are invited to watch the video. Kalman filter applications in oil and gas pipeline systems. Homeland security. Case, defending critical infrastructure in pipeline systems. Those interested in delving deeper into this topic are invited to watch the video. Homeland security defending oil and gas critical infrastructure. The video is based on the paper Defending Critical Infrastructure. Critical infrastructure protection. Development of tools to anticipate, identify, and measure the risks to which a nation or region's critical infrastructure is exposed. This is to reduce the risks and consequences of an attack. B-level and tri-level optimization models to make critical infrastructure more resilient against terrorist attacks are used. Each model features an intelligent attacker, terrorists, and a defender, us, information transparency, and sequential actions by attacker and defender. 3 real examples are presented. The U.S. Strategic Petroleum Reserve, the U.S. Border Patrol at Yuma, Arizona, and an electrical transmission system. Each exercise gathers open-source data on a real-world infrastructure system, develops an appropriate B-level or tri-level model, and uses these to identify vulnerabilities in the system, or to plan an optimal defense. Oil refining optimization includes a generic model that can serve interchangeably to plan the crude and/or biomass refining processes that may be spatially detailed in all units used in the production of refined products. The image shows the main models associated with the operations in the oil refining and petrochemical plants. Those interested in knowing the topics to learn in this part, Hi invites them to watch the video. Enterprise-wide optimization in process industries. Case: oil refining. Mathematical models. The central process of tactical optimization of production and energy management is related to the integration of the two systems, through integrated mathematical modeling. These services often include self-generation, cogeneration and the exchange of energy with the interconnected electricity system. The objective of the model is to minimize the consumption, or cost, of the energy required by the industrial processes, supported by the industrial services plants. The industrial services system is coupled with the production process model to holistically optimize the transformation of crude oil into refined products. The simultaneous optimization of both industrial production and energy conversion is related to polluting emissions of gases and liquids, associated with increasingly demanding environmental control laws. Hi may integrate complex industrial process models to redesign the power supply system, according to the new power technologies. This type of model includes the simulation of polluting processes to determine the optimal mixture of fuels, in accordance with environmental regulations. Water consumption minimization in industrial complexes. Natural gas supply chain optimization. Those interested in learning more about this topic can watch the video. Use case: Oil Express natural gas field exploitation planning. Maintenance of oil and gas assets. The mathematical models required to carry out this work can be classified into two types: models for optimization of maintenance activities, and models to support the general maintenance management. The maintenance of industrial plants, associated with production plants, or process units, that make up the large industrial facilities. These processes may involve shutdown of plants/units, or duration of production leading to a decrease in the productivity of the industrial asset. Those interested in learning more about this topic can watch the video. PHM, Prognostics Health Management. Optimal maintenance of industrial asset networks. Land distribution of oil products and coordination of inventories in regional storage systems. The image shows the main models associated with the distribution of oil products. SANDOP and ALM, integration of production, finance, and taxation models. ERM is a scientific approach to shaping risk, which is based on trading research methods such as applied probability and statistics, stochastic simulation, and investment portfolio optimization. ERM is a rigorous approach to quantifying and managing risks, from all sources, that threaten the achievement of an organization's strategic objectives. In the case of integration of production and finance, there are originally two models, S&OP and ALM. These models can be summed, resulting in a mathematical model containing the constraints of the two models, forming the S&OP ALM model. The user will have three models, the original ones and the integrated model. The integration process can be conceived as the S&OP model that generates results, production and sales, which must be transformed into financial results, in the ALM model, in such a way that the financial statements of the organization are produced, the control of which is the true objective of a private company. The traditional thing is to coordinate the two models, in such a way that the productive model feeds the financial model. This process has no feedback, and therefore the financial model can be a workbook in Excel. The modern vision is to integrate the two models into a single model, which has significant advantages. It's a feedback model between the two systems. The field of control is expanded, as it is possible to introduce financial constraints into the production model, for example, cash flow constraints. Financial variables can be entered as part of the target function, e.g., the value of the firm at the end of the planning horizon, and achieve optimal solutions, which are not obtained with the coordination of models. Theme plan. The course director is the founder and scientific director of RCADT. Engineer Velasquez Bermudez's experience in applied operations research dates back to 1972, which means that he has accumulated more than 50 years solving real-world problems, doing engineering consulting using mathematical models. This is the technology transfer that those attending the course will receive. The table summarizes the plan of topics to be discussed. Continuation of the previous table. RCADT is the most applied academic center in the integration of the teaching of mathematical programming and artificial intelligence. For more information you can consult the URL. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." Thank you for your attention.